Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 6-3 Part 1 homework solutions on applications of vectors. For this problem, we're trying to find the point 1/7 of the way between these 2 points. So to do this, we're going to get the component form of the vector from A to B, basically directions to get all the way from A to B. So we have 5 minus 1, comma, -4 minus 4, which gives us 4, comma, -8. That's directions to get all the way from A to B, but we only want to go 1/7 of the way. So we're going to start at our first point here, 1, comma 4, and to that we are going to add 1/7 of this vector right here. So going ahead and doing that, we've got 1, comma 4 plus, now we're going to distribute the 1/7 to this vector. So that's going to be 4 over 7, comma, -8 over 7. Now we're just going to add the x's together and the y's together, and that'll give us our new point. So we've got 1 plus 4 over 7, that's 7 over 7 plus 4 over 7, or 11/7 for the x value. For the y value, we have 4 plus -8 over 7, so that's going to be 28 over 7 plus -8 over 7, which is 20 over 7. On this problem, we're trying to get 5/6 of the way from point A to point B. Let's begin by figuring out how to get all the way from A to B with the component form. So that's going to be 7 minus -5, so 7 plus 5, comma, -19 minus -1, or plus 1. So that gives us a component form of 12, comma, -18. So we're going to start at the point -5, comma, -1, and to that we are going to add the 5/6 of the vector, 12, comma, -18. And let me just put a p out in front of here to let us know what we're actually doing. There we go. So we have this point that we're starting at, -5, comma, -1, and now we have to take 5/6 of this vector. So I'm going to just divide by 6 and multiply by 5 for each of these. 12 over 6 is 2, times 5 is 10. And now we've got -18 over 6 is -3, times 5 is -15. So there's our new vector, directions to get 5/6 of the way from A to B. Let's just add this vector now to the original point. So that's going to be -5 plus 10, which is just 5. And then we've got -1 plus -15, which is -16. For this problem, we're trying to find the point that is 1/3 of the distance from point A to point B. So we're going to start by finding the directions to get all the way from A to B, the component form of this vector. We'll do the x's and the y's separately, just subtract b minus a. So we've got 8 minus 2 for the x values, 10 minus 7 for the y values, giving us a component form of 6, comma, 3. Next, we're going to start with the first point, point A, that's 2, comma, 7, and to that we are going to add 1/3 of this vector we just found. So doing a little PEMDAS and distributing that 1/3, we've got the original 2, comma, 7, plus now this new vector is going to be 2, comma, 1. And we just have to add these together. So that's going to be 4 for the x values now, and 7 plus 1 gives us 8 for the y values. On this problem, we're trying to figure out the point that's 1/4 of the distance from A to B. So for that, we need the whole displacement for x and y values, the component form. We'll do 5 minus 1 for the x values, and then -4 minus 4 for the y values. That gives us a component form of 4, comma, -8. To get the point 1/4 of the way, we have to start at point A, 1, comma, 4, and to that we have to add 1/4 of this vector. So that's 1, comma, 4 plus, this will now be, let's see, 1, comma, -2. Adding these together, that gives us the new point. If we add the ones, we have a 2 for the x values, and 4 plus -2 is also 2 for the y values. So 2, comma, 2 is the point we're looking for. On this problem, we want the distance between these 2 points in 3-dimensional space. So here's our super distance formula, which has the original x and y squared elements in it, but also has this space for the z values. So going through, we have 0 minus 2 squared for the x values, 3 minus 5 squared for the y values, and 1 minus -3 or 1 plus 3 squared for the z values. So let's see. That ends up being 4 plus 4 plus 4 squared is 16. So 24 altogether. We can simplify that radical. This is really 4 times 6, so 2 radical 6 if we simplify that. To find the distance between these 2 points in three-dimensional space, I'm going to start by just writing the 3D distance formula, which is essentially the 2D distance formula, but with this extra spot for the z values as well. Still square rooting everything here. So doing the x's now, we've got 0 minus 8 squared. Then for the y's, 2 minus 3 squared. And for the z's, 7 minus 6 squared. So this is going to be 64 plus 1 plus 1. So 66. And 66, well, the only factors of 66 are 2, 3, and 11. We can't simplify this radical at all, so we're calling this one done. For this problem, we just want the distance between these two three-dimensional points. So we're going to do the square root of, and now we have to do x2 minus x1. I'll just write out the formula here. x2 minus x1 squared, y2 minus y1 squared, plus z2 minus z1 squared. So we've got negative 10 minus negative 5, or plus 5, being squared. And then we have plus 6 minus 3 squared, and then plus 5 minus 7 squared. So going through and just crunching the numbers here, because they want simplest radical form on this. This is going to be negative 5 squared, so 25, plus this is going to be 9, plus 4. So that's going to come out to, let's see, 38. When all is said and done, 25 plus 9 plus 4, 38. And we can't really simplify radical 38 anymore, so we are actually done. On this problem, we're trying to figure out three-dimensional distance between these 2 points. So to do that, we use our 3D distance formula, which has spots for the x values, y values, and now also the z values. So here's the x values. We've got negative 7 minus negative 1, or plus 1. And then we have the y values, 11 minus 5. And we're squaring each of these differences here. And then finally for z values, 5 minus 8 squared. So this is going to be 36 plus 9. 72 plus 9 is 81, so we have the square root of 81, which we know is 9. For this problem, we're trying to find the midpoint of these 2 points in three-dimensional space. So we use our super midpoint formula, which we're basically just averaging the x, y, and z values. So we've got the x values, 5 plus negative 7 over 2. And then the y values, negative 5 minus 9 over 2. And finally, the z values, 5 plus 1 over 2. Going through now and doing each of these, this is going to be negative 1. This will be negative 7. And for the z values, we have 3. To find the midpoint of these 2 points in three-dimensional space, we use the super midpoint formula. So we're averaging the x values, the y values, and our midpoint formula now also has a place for the z values. So for the x's, we've got 4 minus 16 over 2. And then for y's, we have 1 plus 5 over 2. And then finally for the z's, 12 plus 10 over 2. Averaging each of these, this is negative 12 over 2, or negative 6. And then for the y's, we have 3. And for the z values, 22 over 2 gives us 11. On this problem, we want the midpoint of these 2 points in three-dimensional space. So here's our 3D midpoint formula. We're essentially averaging the x, y, and z values together. So for the x values, we've got 2 plus 4 over 2. Then for y's, we have negative 9 plus 5 over 2. And for z's, 12 minus 2 over 2. Going through each of these, this is going to be 3, comma, let's see, negative 4 over 2 is negative 2, comma, 10 over 2 is going to be 5. To find the midpoint of these 2 points in three-dimensional space, we use our 3D midpoint formula. So average the x values, y values, and z values together. Plugging things here, we've got the x values of negative 2 plus 10 over 2. For y values, that's negative 13 minus 7 over 2. And for the z values, negative 2 minus 4 over 2. So this is going to be 8 over 2, which is 4, comma, negative 20 over 2 is negative 10, comma, negative 6 over 2 is negative 3.